Chapter 2, CHM 271, Thermochemistry. This is the topics in thermochemistry, exothermic and endothermic reactions, enthalpy change, enthalpy of combustion, enthalpy of formation, enthalpy of neutralization, determination of enthalpy change of reaction, using standard enthalpy of formation, calorimetry, simple calorimeter and bomb calorimeter, Hess law and calculation. Learning outcomes. At the end of this lesson, students should be able to differentiate and explain the characteristic of exothermic and endothermic reactions, energy profile of reactions, and activation energy concept, define the terms enthalpy, enthalpy of reaction, enthalpy of combustion and enthalpy of formation, solve problems involving calculation of enthalpy change of reactions, formation or combustion, heat change in calorimetry and Hess law. What is thermochemistry? Thermochemistry is the study of heat change in chemical reactions. Energy change in chemical reactions, thermal energy, the energy associated with the random motion of atoms and molecules, temperature, a measure of the thermal energy. So, temperature is not same with the thermal energy. Heat, the transfer of thermal energy between two bodies that are at different temperatures. Heat always flow from a hotter object, which means this one temperature, high temperature, to a cooler object, low temperature, and stops when reaching the same temperature. Heat of reaction, the total heat absorbed or liberated in a chemical reaction. Exothermic and endothermic reactions. Exothermic reaction is a reaction in which the heat is released from the system to the surroundings and shown by a rise in temperature. You see the reaction vessel becomes warmer due to temperature inside reaction vessel increase. So inside the vessel, the temperature increase. Energy of the reactants is greater than energy of the product. Enthalpy change of reaction is negative value. So the heat inside the vessel will release from the system to the surroundings. The combustion of hydrogen gas and oxygen is one of many chemical reactions that release considerable quantities of energy. This is the example of the exothermic reaction. Endothermic reaction is a reaction in which the heat is absorbed to the system from the surroundings and shown by a decrease in temperature. Reaction vessel becomes cooler due to temperature inside reaction vessel decrease. So inside the temperature is decreased and the heat is absorbed to the system from surrounding. Energy of the reactants is less than energy of the product. Enthalpy change of reaction is positive value. So this is the example of the endothermic reaction. The decomposition of mercury 2 oxide at high temperature. So this is the equation. So this is the exothermic, heat given off by the system to the surroundings, and endothermic heat absorbed by the system from the surroundings. So this is the energy profile, which is the reactants higher than the product. So the energy of the product is greater than energy of the reactant for endothermic reaction. Energy profile for the activation energy is the minimum amount of energy of the reactant molecules required in order to form products. On an energy profile, the activation energy is measured from the energy of the reactants to the peak of the energy profile diagram. The lower the activation energy, the faster the reaction will proceed. So this is the enthalpy change, is the amount of energy absorbed or released by the reaction. On the energy profile diagram, enthalpy change is measured between the energy of the reactant and the energy of the products. So this is the exothermic reaction. So this is the progress of reaction. The product have a lower energy than the reactants, and so energy is released when the reaction happens. Molecules have to possess enough energy, called activation energy, to get the products. So the temperature of the system decrease, temperature of the surrounding increase. For the endothermic reaction, the product have higher energy than the reactants, and so energy is absorbed when the reaction happens. Temperature of system is increased and temperature of surrounding is decreased. The difference between exothermic and endothermic, for the energy absorbed or released, the energy is released for the exothermic reaction. Energy is a product of the reaction. Reaction vessel becomes warmer. Temperature inside reaction vessel increase. For endothermic reaction, energy is absorbed. Energy is a reactant of the reaction. Reaction vessel become cooler. Temperature inside reaction vessel decrease. Relative energy of reactants and products. Energy of the reactants is greater than the energy of the products. Energy of the reactions is less than the energy of the products. The sign of enthalpy change for exothermic is negative, and the sign of enthalpy change for endothermic reaction is positive. And this is the table, the example of exothermic process and endothermic process. So you can look the example of both process